I'm going to go through a couple of examples of constructing a differential equation with a specified general solution. And so in my first example, I'm going to construct a differential equation with this being its general solution, y equals 2t minus 5 plus some constant divided by t. And so that's the question. So the question is to construct the corresponding differential equation. How can we approach that? Well, if this is y, then a differential equation, it relates y and y prime. So let's find y prime. Y prime is going to be 2 minus 5 derivative is 0 plus c over t. So the derivative of 1 over t is negative 1 over t squared. So minus c over t squared. Well, it means that we have this equality and this equality. So both of them are they relate the unknown function to the constant. But this constant is the attribute of a solution of a differential equation rather than the differential equation itself. So which means that in order to construct the differential equation, we need to exclude the constant from these two equations. The simplest way to do it is to express c from the first equation, to express c from the second equation, and equate them together. So from the first equation, c equals, well, here to find c, we need to move 2t minus 5 to the left-hand side, multiply by t. So then we are going to get t times y minus 2t plus 5. Yeah. From the second equation, to find c, we need to again move 2 to the left-hand side and then multiply by t squared. And so at the same time, this equals, well, because of the negative sign here, I will have minus t squared times y prime minus 2. Well, so c equals this and this at the same time. So which means I can just forget about c and equate these two together. And then I can cancel by t. And I get this. And this is basically the answer. Only let me rewrite it nicely. So y minus 2t plus 5 equals minus t y prime. Minus and minus plus. So plus 2t. So now moving everything to the left-hand side, I'm going to get t y prime plus y minus 2t minus 2t minus 4t plus 5 is 0. And this is basically the answer, but it is a good idea to verify it, and I challenge you to do it. So a little bit of homework for you is to solve this linear differential equation to see that, to make sure that its solution is exactly this formula. All right, I hope this is clear. So let me give you another example. We need to construct a differential equation whose general solution is sine of t plus constant. So how do we do that? Well, and again, this is the general solution. A differential equation relates an unknown function and its derivative. This is the unknown function, so we need to find its derivative. Y prime equals, differentiating with respect to t, we get cosine of t plus c. And then we need to exclude c from these two equations. Well, in order to do it, notice that this is sine, this is cosine, and what is the most fundamental relation between sine and cosine? It's that Sine square of anything, say alpha plus cosine square of the same thing is 1. So applying it here, sine square of t plus c plus cosine square of t plus c is 1. So y square plus y prime square is 1. And solving for y prime, we get y prime equals square root of 1 minus y square. And this is actually the correct answer. And as homework, I challenge you to verify this. So solve this differential equation. It is a separable differential equation to see that its general solution is indeed y equals sine of t plus c.